I'm going to go through a worded problem that will require you to use calculus and a bit of imagination on solving this. So the question initially seems really complicated, but it's a matter of just understanding what do they want the derivative, and so on. So it's not too impossible to do. So I would recommend pausing, trying this on your own as much as you can, spend about 5 to 10 minutes on it, and then come back and pause with each section just to see how I'm solving it. So I've assumed you read the question here. Note of the domain goes from negative pi to pi. This is a calculus question, means that you need to deal with radians. Be careful, because the derivatives only work with radians and angles, because we're dealing with cos here. So we have this shape, and we're concerned about this rectangle that's inscribed in there. So let's just put all the points in here. So this is x0. And the point C is this complicated x2 cos 1 over 2 x. So seems a bit odd, but just take it as a number here. So part A wants you to write an expression for the length of AB. Well, it's precisely a rectangle it's inscribed. It means that it touches all the corners. So it's going to be on an equal length. So AB, on an exam they'd give you more information as well. So if this length is x, it means that this length is x, and so you have an equal, you have 2x in here for AB. And the height BC basically takes the length of the y-axis, so this value here, which is precisely the y-coordinate of your C. So BC is exactly 2 cos half of x. So that's for part A. For part B, they want you to write an expression for the area of the rectangle, and we're going to name it A of x, and it has to be in terms of x. Now A of x, so we have the rectangle here, A, B, C, D. The area is going to be length times height. We have AB and we have BC. That's for part A. So the area is going to be these two multiplied with each other. So 2x times 2 cos a half x. And I'm going to simplify it, so that's going to be 4x cos a half x. And I just double check that everything is in terms of x, which it is. So we are good here. Now, part C wants you to find the derivative, so we're going to derive that part A, and the derivative is going to basically ask you to use the product rule and the chain rule. So I'm going to differentiate for x first, which is going to give me 4. And then I'm going to derive the cos, which is going to be, it's going to give me a negative sign. We derive the internal, that's going to be half, times the 4x stays the same. So if you're not sure about what I did, please watch the derivatives of trigonometry. So simplifying this, I'm going to get minus 2x sine 1 over 2x. So that's the overall answer for the derivative. Now, part D wants you to use your answer from part C to find the value of x for which the area is a maximum. So you could do it in different ways. Because this is a calculator paper, I would recommend you use the calculator for this. So the point is, we know that it's a maximum or a minimum when the derivative is equal to 0. So we want to see when is the output equal to 0. On our curve. Now, in a normal situation, if it's a non-calculator paper, you would want to use you would want to do this algebraically, but because this is like a more complex sine cosine thing. So this is the graph of the derivative. And we want to know when is the derivative equal to 0. In the calculator, you go to second calc, and then you click on zeros. Now, we have two options, either here or here. But we are talking about area. We're talking about an actual length. So we need a proper x, because note that this is where the x is by the definition, so x has to be in the positive x-axis. So it doesn't make sense to take this negative value of x, it has to be this positive value of x. So in the calculator, you're going to go left bound, right bound on this x here, and it's going to give you 1.72. Another method is to look at the gradient as well. So the gradient here will be a positive. Remember, this is the gradient graph. So the gradient here is positive. Look at the output. And the gradient here is negative. How do I know? Because it's in the negative y-axis. So the gradient is negative, and this is positive y-axis, so positive. So positive and then negative. So you're having a positive, no gradient, negative. So you have this maximum behavior. So x is 1.72. You can do it any method. You could use the critical value table as well if you want to. But again, keep in mind that a prime is equal to 0. This is the graph of it. So we're looking either for this or this. One of these is the maximum. We're assuming x equals to 1.72. Now, it says use your GDC to plot the graph of a of x, so the original, and verify that your answer for part D, find the maximum area of the rectangle. So we have a couple of things in this question that we need to do. Usually in an exam, they won't actually ask for D and then E. This is more of a classwork type question. So you would actually intuitively want to use your GDC to make sure that 1.72 is a maximum. So let's look at that. This is the graph of the actual A of x. And you'd notice that the maximum appears here. This is all the combination of x's that would give you this area. So if I pick this x, it's going to give me a negative area. If I pick this x, it's going to give me a 0 area. If I pick this x, it's going to give me this maximum area, and the area is my output here. So obviously this matches with the 1.75 or 1.72, sorry. The negative would have given me a negative area, which doesn't make sense in this question. So we have x equals to 1.72, so we verified that this is the maximum. In questions where you can't use the critical value table or you can't use the second derivative to test, or in questions that you are allowed to use a calculator, you can just use the calculator to graph them on top of each other. For example, I've graphed both the derivative, which is this kind of parabolic, it's not actually parabolic, but this curve down. And you have the original with just this wave thing. And as you can see at 1.72, you have this maximum behavior here. So the derivative is 0 at that point, meaning it's a maximum. And be careful, the question wants the maximum area of the rectangle. So I then substitute it in the original. And once we put it in there, it's going to give me 4.49. It's in units squared. So that's kind of how you'd answer this question. So for questions that seem quite complex, just break them down into parts that you would actually understand, use the formulas that you need, go back into, even if things are complicated as coordinates, you know what the derivative is, you know how to find it, you know what it means to find a maximum, minimum, and so on. It's just written in a different type of way and asked in a different kind of method. So just be comfortable with different possibilities of asking for applications of derivatives, which mainly come in the form of maximums and minimums.